All right, so in lesson 4, we are talking about the law of sines, and we are using the law of sines to solve for sides and angles in an oblique triangle. Now, what is an oblique triangle? Well, oblique is spelled O-B-L-I-Q-U-E. And basically, it's not a right triangle. So with our trig ratios, we've been working with right triangles. But this triangle, as you can see, is not a right triangle. Neither of these angles are right angles. And so you can't use SOHCAHTOA in order to solve for these. However, one of the things that you can use is the law of sines. So if you have a triangle with angle capital A, B, and C, and you're going to see this triangle a lot with law of sines. This opposite side of capital A, angle A, is going to be side lowercase a. All right. Also could be called side BC. This opposite side of this capital C would be lowercase c. Okay. Also be called BA. And then this opposite side of angle B, of course, if this is a capital B, this would be lowercase b. And the reason that we do this is so that it corresponds to the formula. So first we want to look at this formula. We have sine of angle A divided by side A is equal to the sine of angle B divided by side B is equal to the sine of angle C divided by side C. All right, and this works for every triangle, okay? So all you have to do is take the information that is given, plug it in, and then just set one of these proportions equal to one another, and they should give you the same thing, all right? Now, if these fractions should be equal, then their reciprocal should also be equal. So that means if I flip these fractions, and now I have side A over the sine of angle A, that should still be equal to side B over the sine of angle B. And that should be equal to side C over sine of angle C. All right, so all we did there was flip those fractions. So either way that you want to set those up, they should work out for you. Let's give it a try. So let's look at what's been added here. We have that angle A. The measurement is equal to 47 degrees. We have this side on the bottom is equal to 6, which is side B. And then we have this side over here is equal to 9, which was side A. All right, so do we have enough information in order to figure out what is the measurement of angle B? So let's look at what we have. We got angle A and side A. So we'll be able to figure out exactly what this whole thing is. And then we have side B, but we don't have sine of angle B. But since we're solving and we got all three of these things, we'll be able to figure it out. Let's set it up. So since we're given this information right here, all we have to do is plug it into the law of sines in order to solve for angle B. So we had the sine of angle A, which is 47. And I should have that over side A. So remember, side A is all the way across from angle A, which is 9. And that should be equal to the sine of B, which I don't know B, so I'm going to leave that like that, over the side B, which is opposite of angle B, which is 6. That's how we set this up. Then, we know we have a fraction equals another fraction. We can cross multiply in order to figure out what is B. So remember, to cross multiply, all I do is take the numerator times the denominator here, and I set that equal to the numerator times the denominator here. All right. So we can just write that with the 6 in the front. 6 sine 47 should be equal to 9 sine B. Now remember, we're trying to get B by itself. So I have two things going on over here. I'm multiplying by 9, and I'm taking the sine of B. But the first thing I can get rid of is this 9. So what would I have to do to both sides to get rid of the 9? I need to divide. So when I divide by 9 on this side, it cancels. Over here, I'm just going to rewrite what I have. All right, here's where it gets tricky. So when we're looking for an angle, usually we're going to end up with the trig ratio with that angle that we're looking for. How do I get rid of the sign so that B is by itself? Here's a hint. What did we do in lesson 3? I have to take the inverse sign of both sides. When I do that, that gives me a B by itself on this side. This entire thing goes in the calculator. Another thing you can do is go ahead and multiply 6 times sine 47, divide that by 9. And if you want to put that decimal into the inverse sign, you can. But you can totally do all of this in one step as well, depending on what type of calculator you use. Using the Desmos scientific calculator that you can easily pull up on your cell phone, if you put this part of the calculation in, you end up with 29.180. So the 0 tells us we don't have to move anything with our 8. And that means that B is about 29.18 degrees. So before we move on, or if this is the end of our problem and we were just looking for the measurement of B, we want to plug these values back into the law of sines to be sure that they give us the same decimal. Same way we used to check in lesson 2 and 3. Now remember, we did round this 29.18. So if you don't necessarily get the same identical decimal, sometimes that's okay. Now you shouldn't get a 0.5 and then get a 0.7. Those two are clearly different things. But if by the third decimal point, maybe the number is different, that's still okay because remember this value is rounded. So all I did was took sine of angle A from our triangle and I put that over side A. And then I put sine of angle B because we know what that is now. And I put that over side B. Now when I put these two things in the calculator, they should give me the same decimal. Let's see. Beautiful. Sine 47 over 9 gives me 8/100. Sine 29.18 over 6 gives me 8/100. Voila. Beautiful math.